are welcome to CRSM virtual class. I am Fakoya Oluwabumi. I shall be taking you English studies. And our topic today is Concord. Concord, I'm sure some of you are already familiar with this topic. And as well, some are just hearing it for the first time. And some people may even know it as a subject and verb agreement. Now today, at the end of today's lesson, you should be able to explain Concord. You should be able to highlight some of the rules governing Concord, as well as apply these rules that you have learned. So if you know that even the word of God confirms Concord, can two work together except they agree? You cannot work with someone if you are not in agreement with that person. You can never work with such a person. However, let's not digress too much. Let's go back to the topic of today, which is Concord. Concord is the agreement between subject and verb in a sentence. Subject and verb in a sentence. In other words, the subject and the verb must agree together in a sentence for us to have a grammatically correct sentence. Therefore, what is even subject? A subject can be a noun, can be a pronoun, and can as well be a noun phrase in a sentence. And we are all familiar with a verb, which is an actual word. Now, for us to have a grammatically correct sentence, that means the subject and the verb of that sentence must agree for us to have a correct and a meaningful sentence. Now, today we'll be looking at some of the rules that we use in Concord, some of the rules governing Concord. And what are these rules? Rule number 1. A singular subject takes a singular verb. A singular subject takes a singular verb. In other words, in a sentence where we have a singular subject, we must use a singular verb. For us to have a grammatically correct sentence, anywhere we have a singular subject, we must use a singular verb. Now, I'm sure you have your pen and your papers with you there. You can try and construct a sentence with a singular subject, knowing fully well that a singular subject could be a noun phrase, or a noun, or a pronoun, using singular verb with it. Okay, let me give you an example. Matthew plays a lot. Matthew plays a lot. If you look at this sentence, Matthew plays a lot. If we say Matthew play a lot, you will say that the sentence will not make sense. And of course, it will not be meaningful. It will be ungrammatically correct. If you use Matthew play a lot. But if you use Matthew plays a lot, the person you are conversing with or you are writing to will understand, will have full understanding of the message you are trying to pass across. And that is why, because we have a singular subject, which is Matthew, and we also have a singular verb, which is plays. That is why we have a grammatically correct sentence, because we have used we have used singular subject, we have used singular verb. correct combination. And that is why the sentence is meaningful. And we can also understand what the message the sentence is trying to pass across. Let's look at another example, which is he is hardworking. He is hardworking. He is hardworking. Now, looking at this structure, you'll see that we have a singular pronoun there in the subject position. And of course, we have a singular verb in that sentence. The sentence is meaningful because we have a singular subject as well as a singular verb. You can imagine if somebody comes to meet you and the person is saying, he is hardworking. Does it make any sense to you? You'll be wondering, what message is this person trying to pass across? Because the sentence is not correct. But if the person comes to meet you and says, he is hardworking, easily you'll be able to know what message the person is trying to pass across to you. And of course, the sentence will make sense to you because the person has used the right subject, which is pronoun, singular pronoun, and the person has also used the right verb, which is singular verb. To cap it all, let's look at another example under this rule, which is the man has a car. We don't have the man have a car. Because you'll be wondering, the man have a car? The man have a car? It does not make sense because we have not used the right verb there. We have used have instead of has, which is singular verb. And of course, you see that the noun phrase is singular. The man, not the men. If we have the men, then we can use have. We will still get to that level as we progress in this class. So we have the man has a car. We have the singular verb has, and we also have the singular subject, which is the man. So that means we can use the man has a car. It is wrong for us to say the man have a car. And as well, it is wrong for us to say the man has a car because we have used the plural subject. So the correct structure now for this sentence is the man has a car. Remember, this rule says a singular subject takes a singular verb. I'm sure you have understood this particular rule. We will now move to the next rule. Remember, I told you that the first rule is a singular subject takes a singular verb. Now, rule number 2 now says a plural subject takes a plural verb. A plural subject takes a plural verb. Now, remember rule number 1 says a singular subject takes a singular verb. However, rule number 2 is a plural subject takes a plural verb. I'm sure you will want to try a sentence out with this rule, using rule number 1, applying rule number 1 to construct a sentence for rule number 2. I'm sure you can try that at home. Well, let me give you my own example. Let's look at this example. Matthew and Enoch play a lot. Matthew and Enoch. Matthew and Enoch play a lot. If you observe, we can say that we have a plural subject there because we have 2 people. We have Matthew and we have Enoch. And the rule says a plural subject takes a plural verb. Now, since we have a plural subject, Matthew and Enoch, we must use a plural verb. In other words, it will be wrong for us to say Matthew and Enoch plays a lot. I'm sure you two are saying, very wrong. Yes, because it does not make sense. That sentence does not make sense. But if we use the right subject with the right verb, the sentence will be grammatically correct. It will make sense. And whoever you are conversing with will understand the message you are trying to pass across. So, back to our example. Matthew and Enoch play a lot. You will see that we have used a plural subject with a plural verb. A plural subject with a plural verb. Therefore, it will be wrong to say Matthew play a lot. No. It will be wrong for us to say Matthew and Enoch plays a lot. No. But it will be right for us to say Matthew and Enoch play a lot. Correct sentence. Let's take another example. They are hardworking. They are hardworking. If you look at the structure of this sentence, you'll see that we have a plural subject there, as well as a plural verb. And of course, you know that Matthew is a noun, Enoch is a noun. But now we are looking at using a pronoun with a plural verb. Using a pronoun with a plural verb now, as an example. Now we have a plural pronoun, which is they. And we also have a plural verb, which is her. So we can use these two together to make a correct sentence. And our sentence will be meaningful when we use that. So it will be wrong for us to say, they is hardworking. Oh no. That would be very, very wrong for us to say. But if we say they are hardworking, say good. But as well, it will be very wrong for us to say they is hardworking. They is hardworking. The sentence will not be meaningful and it is not correct. It is very, very wrong. But if we say they are hardworking, the person you are conversing with will understand the message you are trying to pass across and will be able to respond appropriately. But if you use the wrong pronoun, if you say he are hardworking, the person will not be able to understand you, and of course you must have constructed a bad English, ungrammatically correct sentence. So, but if you say they are hardworking, everybody will understand what you are trying to say, and we applaud you for writing a good sentence and for using the right words to converse. Let's take another example on that. The men have cars. The men have cars. If you look at this sentence, you will see that we have a plural subject, and of course we have a plural verb. The men have cars. The men have cars. Now, looking at this structure, you will see that we have a plural subject as well as a plural verb. This is a grammatically correct sentence. It will be wrong for you to say, the man has cars. The man has cars. I'm sure you are saying, that's wrong. Yes, it's wrong because we have not used the correct verb. So it is correct to say, the men have cars. And as well, if we have the man have cars, very wrong. It is very wrong to say the man have cars. No, because we have not used the correct subject with the right verb to construct that sentence. So I'm sure by now you should be able to construct like 4 more sentences applying this rule. Remember rule number 1. A singular subject takes a singular verb. Rule number 2, a plural subject takes a plural verb. A plural subject takes a plural verb. I hope you have been able to understand those 2 rules that we have gone through. Now, that takes us to rule number 3. And what is rule number 3? Rule number 3 states that nouns that are plural in form but singular in meaning take singular verb. You may be wondering at home that what are these nouns? Let's look at this sentence. Mathematics is my best subject. I will say that mathematics is in the subject position, and of course is a noun. Though is in plural form, it is singular, and that's why it takes is as verb in that sentence. That's why we have mathematics is my best subject. If you look at this structure and you remove is, you put her. Does it make sense? Like having mathematics are my best subject. Does it make any sense to you? For the mere fact that mathematics as S does not make it a plural. And that is why it takes a singular verb. Mathematics is my best subject. Therefore, it will be wrong for us to say mathematics are my best subject because we have S in mathematics. And as well, we have so many subjects like that with S. Like physics, we cannot say physics are my best subject. We cannot say economics are my best subject. We'd rather say mathematics is my best subject. Economics is my best subject. Physics is my best subject. Please take note of that. It's an entity on its own. But the mere fact that we have added X does not make it plural. It is still singular. Let's take another example. The headquarters of the company is in Abuja. Now, the word headquarters is in plural form, or however singular in meaning. But the mere fact that we have S added to headquarters does not make it plural. It is still singular. Another example is the news has just been read. The news has just been read. The news is in plural form but singular in meaning. Therefore, it must take a singular verb. So that's why we have the news has just been read and not the news have just been read. It would be very wrong to say the news have just been read, but rather correct, grammatically correct to say the news has just been read. I hope you have taken note of this rule. Rule number 1, a singular subject takes a singular verb. Rule number 2, a plural subject takes a plural verb. Rule number 3, nouns that are plural in form but singular in meaning take singular verbs. On this note, we'll stop today and we'll continue the rules in our next edition. And of course, from our lesson today, I'm sure you have learned what Concord is. You have learned that even the Word of God confirms Concord. Can two work together except they agree? And of course, you should be able to, by now, mention some of the rules governing Concord, and you should be able to apply these rules even to construct meaningful sentences. Against our next class, I want you to write 2 sentences on each of these rules. Thank you. God bless you.
Good day, viewers at home. My name is Ogutunde Olatubosun. I welcome you to CRSM virtual class. And the subject I'm going to take today is mathematics. And the topic is variation. And before I go further, I would like to give definition of variation. What is variation? Variation is the change of some quantities due to change in another. Now, from this definition, we can deduce that our God is proportionate. He will give us according to our work. In mathematics, we usually deal with 2 types of quantity. The first one is variable quantities, and the second one is constant quantities. If the value of quantity remain unaltered under different situations, it is called a constant. That is, when we have a number that is the same throughout, no matter how we change other parameters, then that number is referred to as a constant. Now, what are the types of variation that we have? The first one is direct variation. The second one is inverse variation. The third one is joint variation. And the last one is partial variation. And today, The only one that we are going to consider is direct variation. That is the only topic that we are going to consider for today. Now let's quickly move to direct variation. What is direct variation? When an increase or decrease in one variable leads to an increase or decrease in another variable, such variation is known as direct variation. So it means when one variable is increasing, then the other one also will increase. Or when one variable is decreasing, the other one also will decrease. So this type of variation is what we refer to as direct variation. And then we have in mathematics, we are always have problem to work with. And at the end of every problem, there must be a solution. And under direct variation, we have some steps required for solving direct variation problems. What are the steps that we need to take before we can attend to direct variation problems? Now, the first one is we are going to write correct equation for the problem. We are going to write correct equation for the problem. Now, let's look at this example. X varies directly as y. And from here, we have two variables. The first one is x, and the second one is y. So from this varies directly, it means when x increases, when x increasing, what happens to y? It will increase. Now, the next step is to write the equation for this variation. What is the equation? We have x is proportional to y. This symbol means sign of proportionality. Sign of proportionality. And that is, this alpha in mathematics is, for this particular topic, is sign of proportionality. And the next step now is to change this sign of proportionality to equal to. To change the sign of proportionality to equal to. Then how can we do that? Then we are going to introduce a constant. We are going to introduce a constant. And that constant must be another letter apart from x and y. It must be another letter apart from x and y. And if you look at most textbooks in mathematics, they usually use a k as constant. So if you want to change this one to equal to, it means you are going to multiply your right-hand side with that constant. Now let's assume that the constant that you want to use now is k. So I'm going to have x equal to ky, where k is a constant. Where k is a constant. So this is the final equation of this direct variation. So any other problem that you want to solve based on direct equation, this is where we are going to start from. This is where we are going to start from. Then I go over it again. Steps involved in solving direct equation. Number one, we are going to write out the equation for that variation. We are going to write out the equation for that variation, which is this. Then after then, the next thing to do is to change this sign of proportionality to equal to. Then how can we change this sign to equal to? Then we need to introduce a constant. And I said that that constant should be another letter apart from y, from x and y. So, and then I said that in some textbooks, or most textbooks, they prefer to use what? K. because it is unique among other letters. So now you can see that after this step, the next step, we have changed this sign to equal to by multiplying the right-hand side with a constant k. So any question that you want to solve on direct equation, this is where we are going to start from. Now, let's quickly look at some examples. Now, example 1. Now, let's look at the example 1. Here we have if x varies directly as y and x equal to 9 when y equal to 6. Find x when y equal to 15. So this is the question we have before us. And I said that before we can do anything on this topic, which is a direct variation, the first thing to do is to write the equation for that variation. And when you look at the question, we have two variables. What are the variables? We have x and y. We have x and y. So the first thing we're going to do is that you write the equation, which is x varies directly as y. And this is not where to stop. What is the next thing? We need to change this sign of proportionality to equal to. Change the sign of proportionality to equal to. Then how can we do that? So we're going to multiply your right-hand side with a constant. So we have x equal to ky. So this is the equation for the direct variation. Now you now go back to your question. You will see that we have x. The value for x is 9. And when you go further, we are given another value for y. So these two values is what we are going to substitute into this equation to get the unknown. What is the unknown? That is our constant, the newly introduced letter, which is letter k. Then what is our x? Our x, you substitute, that is 9 equal to, then what is our y? 6. You substitute 6 here, then we have a 6k. Then our result now is 9 equal to 6k. And what is the next thing to do? So we're going to look for how to eliminate the coefficient of k. Then how can we remove the coefficient of k? So it means we are going to divide both sides by the coefficient of k. What's the coefficient of k? That is 6. So we're going to divide both sides by 6. So that will give us 9 over 6 equal to 6k divided by 6. Then this 6 will cancel this. Then the final one is going to be k equal to 9 over 6. So this is not where we are going to stop. So we need to take this to the lowest form. We are going to take this to the lowest form. What is the lowest form? When you look at 9 and 6, both are multiple of 3. Both are what? Multiple of 3. When you look at multiple of 3, it means 3 can divide 9. At the same time, 3 can divide 6. So if we take 3, how many times can we have 3 in 9? That will give us 3. How many times can we have 3 in 6? That will give us 2. Then we have k now equal to 3 over 2. K now equal to 3 over 2. So from here, we can see that the constant that we introduce is equal to 3 over 2. Is equal to 3 over 2. So now, the next we are going to do now is we now go back to this formula. That is x equal to ky. Since we have gotten value for k, then we substitute the value, which is x now equal to, what is our k? That is 3 over 2 multiplied by y. 3 over 2 multiplied by y. From this formula, connecting x and y together, then we can use this formula to solve for the rest question, which is we are looking for x unknown, then y is given to be 15. Then from here we substitute for y. So that will give us x equal to 3 over 2 multiplied by 15 over 1. Then we can see that 2 cannot go in 15. What are we going to do? We multiply the two numerators together. So we have x now equal to 3 multiplied by 15. That will give us 45. Then 2 multiplied by 1. That will give us 2. Then we now take this to mixed fraction. Then how many times can we see 2 in 45? That is 22. Then remainder what? Remainder 1. That is 1 over 2. So from here, the value of x when y equal to 15 is 22 whole number 1 over 2. I repeat, the value of x when y equal to 15 from this formula is 22 whole number 1 over 2. I believe that is clear enough. Now, let's quickly move to question 2. Question number 2. And if P varies directly as the square of Q and P equal to 20 when Q equal to 5, find P when Q equal to 10. Now, from this question, we have two variables, P and Q. Then write out the equation for the variation. We have P varies directly as square of Q. Square of Q. Then what is the next thing to do? Then we change this sign to equal to by introducing a constant K. P equal to Q, P equal to K, then you multiply by Q squared. Then what are the values given? We have P to be 20, then we have Q to be what? To be 5. Then we have K multiplied by 5 squared. Then what is 5 squared? It means we are going to multiply 5 twice. So we have 20 now equal to 25K. Then what is the next thing to do? We divide both sides by 25, the coefficient of K. Then you divide this by 25. Then you divide your left hand side also by 25. So this and this we cut out. Then we have K now equal to 20 over what? Over 25. And if you look at the two, both are multiple of 5. So it makes 5 can divide 20. At the same time, 5 can divide 25. So how many times can we see 5 in 20? So we have K now equal to 5 in 20. That is 4. Then 5 in 25. That will give us 5. So our constant now is 4 over 5. So this one is called proper fraction. So there is no need to take this one to mixed fraction. Why? Because the numerator is smaller compared to denominator. So this is how we are going to have our final answer for constant K. Then after this, what's the next thing to do? Then we are going to write out the formula connecting P and Q. How can we get the formula connecting both of them? So I'm going back to this by substituting for K. Then we have P now equal to, what is our K? Our K is 4 over 5 multiplied by K squared. So this is the formula connecting P and Q. So any other question that you want to solve, so this is the formula to use. Then when we go further, we are looking for P. P unknown, then Q equal to 10. Then to get our P, and from this formula, P is the subject of the formula. Then we now substitute for Q there. Then we have P equal to 4 over 5 multiplied by 10 raised to power 2. What is 10 raised to power 2? So that will give us 4 over 5 equal to 100 over 1. Then from this place, we can see that 100 is a multiple of 5. That is, 5 can divide 100. 5 here, 1, 5 in 100, that is 2. So for P now, 4 multiplied by 20, so that will give us 80. So the final answer for P, when Q equal to 10, according to this formula, is 80. So it means when Q equal to 10, then P equal to 80. So that is the value of P. Now for question 3. The cost of a taxi fare varies directly as the distance traveled. When the distance is 60 kilometers, the cost is 35 naira. Find 1. The relationship between the cost of a taxi fare and the distance traveled. Then 2. The cost when the distance is 84 kilometers. And the last question under that is the distance traveled when the cost is 28 naira. What is the first thing to do? Then from that question, we are given C to represent the cost of a taxi fare, which is C is directly proportional to the distance D traveled. So D represents distance traveled by the taxi. Now, we are given 2 values, one for cost and one for distance. And from here, we need to change this to equation. That is C equal to KB. Now, what is the value for C? We have 35. What is the value for D? That is 60. So we have a 60K. Now, from here, what's the next thing to do? We are looking for K. So the coefficient of K is 60. So we divide both sides by 60. So we have to divide this by 60, then divide this also by 60. So this 60 and 60, both will cancel each other. Then we have K now equal to 35 over 60. Now from here, what can we use to divide the 2? What can we use to divide the 2? Then we can have what? We can use 5. 5 in 35, that will give us 7. Then 5 in 60, that will give us 12. So we have the final answer for the constant now is 7 over what? Over 2. Over 12. Now if you want to find the formula connecting them, then we substitute back. So for the solution to the Roman figure 1, that will give us C equal to 7D over 12. So it makes this is the formula connecting cost of the taxi and distance traveled. So cost of the taxi and the distance traveled. Roman figure 2. We are looking for the cost when the distance is 84 kilometers. So this is the formula to use when we want to solve any other question. So we have C equal to 7D over what? Over 12. Then what is the distance traveled? The distance traveled is 84. That is, we substitute 84 for D. That is 84 divided by 12. Then our C now equal to, when you look at 84 and 12, 84 is a multiple of 12. So it makes 84 can, 12 can divide 84. So 12 here, 1, 12 in 84, that will give us 7. So the final answer now is 7 multiplied by 7. That will give us 49. But don't forget one thing, that the cost there has a unit. What is the unit of that cost? There is naira. So I'm going to write, therefore, the cost is 49 naira. So it makes when the taxi man traveled distance of 84 kilometers, the price is 49 naira. So that is that. So now we are looking for the distance when C equal to 28. The distance is unknown. So we have C now equal to 7D over 12. So we substitute 28 here. That is 28 equal to 7D over 12. Then cross multiplication, we have a 28 multiplied by 12 equal to 7D. Divide both sides by 7. So D now equal to 7 here 1, 7 here 4. Then 4 multiplied by 12. That will give us 48 kilometers. So it makes when the cost is 28 naira, the distance traveled is 48 kilometers. Now let me summarize all that we have discussed so far. Now, 1, variation is a change in some quantities due to a change in another. Then number 2, direct variation is proportionate change in two variables. And the last one, to change a variation to an equation, a constant is introduced called variation constant or proportionality constant. Take this exercise as assignment, and the exercise is displayed on your screen. And by the time I come your way, next time, I will provide solution to all the assignment. Thank you, and God bless you.